For a brief while, 24-year-old Cambridge Ph.D. student Jocelyn Bell Burnell nicknamed signals emanating from the Vulpecula constellation that November day in 1967 as LGM, or Little Green Men. The specificity of the intervals of the signals at 1 1/3 seconds at least teased the possibility that they were coming from an extraterrestrial civilization. However, as soon as she detected the signals from three other sources, she knew that the chances of them being signals from extraterrestrials were ridiculously small. As it turned out, the pulses suggested the presence of something that had only been theorized in 1934: neutron stars. Since these extremely dense stars compose almost entirely of neutrons and packed generally within a diameter of 20 miles, pulsate like a cosmic lighthouse, they came to be known as pulsars. It was a revolutionary discovery of objects that had only been theorized until then. In making the discovery was a 24-year-old student under the supervision of Dr. Anthony Hewish. Although the radio telescope and related equipment were built by Dr. Burnell, apart from actually detecting the pulses, it was Dr. Hewish who was awarded the Nobel Prize in 1974 along with Martin Ryle. The sheer injustice of Dr. Burnell being denied the prize created quite a storm among the astrophysics community then, even though she has approached the glaring omission without any rancor. The discovery of pulsars is one of astrophysics' most extraordinary stories, and at the heart of it is the now 81-year-old, the ever amiable Dr. Burnell. She spoke to MCR.
Welcome to my entire reports, Dr. Burnell. It's a great pleasure to have you.
Thank you.
58 years too late, but congratulations nevertheless on your astounding 1967 discovery of pulsars.
It was a while ago, yes.
Yes, indeed. Indeed. Your life has two extraordinarily parallel tracks. One is cosmic and hence grand. The other is worldly and hence mundane. I hope to be able to talk about both. So let's begin with something grand like the cosmos. It was November 28th, 1967. You were a 24-year-old PhD student at a field with 120 miles of radio telescope outside Cambridge. Tell me what happened.
First thing I think to say was I had been in other parts of the UK. This was my first time in the deep south of Britain, and I was quite overawed by the apparent brilliance of all the males in Cambridge. There were very few females at that stage. We were, I think, under 10% of the population of Cambridge, and at graduate student level, probably even smaller than that. So I arrive in this strange part of the country to be confronted by a lot of apparently very brilliant people, certainly full of self-confidence.
Okay. You used an interesting term, apparently brilliant. Tell me why.
Sorry, I don't...
I said you used an interesting term, apparently brilliant.
Yeah, okay, yes, yeah. Well, they'd walk around the streets talking in loud voices about what Hegel had said and not said, and that kind of thing. It was quite simply showing off, but at the time I didn't recognize it as such.
I see. I was very struck by that particular day when you first recorded the pulses. Tell me what was the day like? What was the atmosphere like? It was what time of the day that you noticed it?
Oh, I wonder if I can remember at this distance. I suspect it was afternoon.
Okay.
I'm not too sure. It was November, so it's a grey, British November weather day.
I see. Now, I was reading up your background quite a bit, and I was wondering if in those days, when you read the data, was it in real time or did you analyze it after you saw it?
You analyze it later. You record it on long strips of paper chart.
Okay.
And then you roll up these strips of paper chart, take them back into Cambridge to the office and do the analysis there.
So it involved a lot of grunt work, as it were, right?
Oh, an awful lot, yes.
Huge amount. Describe to me that, because I think a lot of young scientists do not realize how much of detail-oriented work it really is to be able to come up with what you came up with. Tell me a bit more about that.
Well, I spent the first 2 years in Cambridge helping build the equipment that I would use. So it involved a certain amount of hammering with a big, what we call a sledgehammer. I became very strong. Quite a lot of use of soldering irons and things like that. So 2 years helping build the equipment. And then my third and final year using it, analyzing the data, writing up the thesis, etc.
But that means you were really hands-on.
Oh, yes, absolutely.
Which was something, I suppose, unheard of for a lot of scientists, because science, the outside impression of a scientist is someone who is in this rarefied atmosphere thinking away. But the way you're describing, including soldering, it's quite remarkable.
Oh, yes. I'd say scientists divide into two camps. The theoreticians, who spend their time thinking and scratching their heads, and the experimentalists who are using equipment, and in my case, constructing the equipment first.
Right. Did you get a patent on that? Since you made it? Yeah, I mean, since you created that equipment yourself.
But I didn't pay for it.
Okay. Tell me about the first time you noticed the pulses, because reading it sounds quite dramatic. I would like to hear from you when you were looking at the charts. What were you thinking?
Well, to begin with, I was noticing there was an anomaly that I couldn't explain. And it's all jammed into about 1/4 inch of the chart paper. I have these very long strips of chart paper.
Right.
1 hour's observation takes 1 foot of paper. And I'm observing for 6 months, so I have a lot of feet of paper.
And in your mind, did you know what you were looking for at that point?
Well, I knew what I was looking for, but it wasn't that.
Okay.
This was an anomaly.
Oh, I see. And why do you call it anomaly?
Because it wasn't what I was looking for. It wasn't my project topic.
And what happened when you saw that? What was your first gut reaction to it?
Well, to begin with, you don't know exactly the nature of this signal. It's just something different on these yards of chart paper. And I noted it once or twice with a question mark because I couldn't understand what it was. And then finally it clicked that the question marks were coming in the same part from the same part of the sky. But it still only occupied, 1/4 inch on these feet of chart paper. So you didn't really know what it was. You needed an enlargement, if I could describe it that way. So that meant going out to the observatory at the proper time of day when the telescope was looking at that bit of sky that was producing the funny signal. So you'd go out to the observatory, you'd switch the chart recorder to run much faster. So the chart paper goes faster under the pen and all the signal gets enlarged. And I did that. This signal was very close to threshold. Mm-hmm. A number of days it wasn't visible. And so I was making these special recordings of receiver noise.
Okay.
But finally, after probably half a dozen attempts, it kindly performed for me, and in came a string of pulses.
Would you tell me which part of the sky it was coming from? Would you remember that now?
It's constellation of Vulpecula.
I see. And how far would that be?
You can't tell distance. You can only tell direction.
Oh, I see. I see.
So when I say the direction, it's in the constellation of Vulpecula. So it's that little bit of sky.
Okay. When you detected a string of pulses, you have said that 1 1/3 seconds apart. That's the specificity of the pulses. And that
Yes.
perhaps triggered your curiosity that they were so specific.
No, that it was pulses at all was surprising. I expected some fairly random signal.
I see. But did you, at that point, ask yourself what the signals could be? It could be any number of things, including human interference, right?
Yes, that's right. Yes. Yeah.
And so, how did you manage to filter out noise to signal thing?
The strength that these signals had is they always came from the same bit of sky.
I see.
If I looked at any other bit of sky, I didn't see these pulses.
Okay. And I believe when your first radio telescope registered, you started thinking about it, and then you moved on to the other one, which did not register for a bit.
Yeah, let's see if I can remember exactly. The first one was probably one of the strongest.
Okay.
I found the first 4. So the first one is the strongest. And then when you realize what it looks like on your chart recording, you begin to see more. And so I found a second, a third, and a fourth, all in a period of a couple of months, probably.
And since you were a student at that point, you called your supervisor Professor Hewish, I believe.
Mm-hmm.
Tell me about his first reaction, because I have seen your video interviews and I know what his reaction was, but I would like you to share it with my viewers if you don't mind. What was his? It almost sounds dismissive to me.
No, he's cautious, particularly when there's only one. He wants to be really sure that it's not some kind of radio interference, because we have this enormous, very, very sensitive radio telescope, and it will pick up interference. So one of the first tests was to consult a colleague of his who also had a grad student who had a radio telescope that worked in the same band as mine.
Okay.
I asked them if they could pick up this funny signal, or whether it was some wiring fault with my telescope, perhaps, something like that. And they did pick it up, which was good, which makes one believe it's at least way beyond the observatory, but it could still be terrestrial.
Okay.
It could be radio interference, pirate radio stations, police radio cars, all sorts of things we can pick up with radio telescopes.
Okay. Yeah. But at that point, neutron stars were known, but pulsars were not really labeled at that point, right?
I'm not sure that neutron stars were known. Some mad theoreticians have suggested they would exist.
I see.
But until they were found, nobody really believed the theoreticians, except the theoreticians.
I see. So, I mean, what we are saying is, of course, they are known more popularly as pulsars. Yes. You were at the heart of in discovering neutron stars, right?
Discovering that they actually existed,
right.
Yes.
Right. Yeah. I mean, the first experimental evidence that they exist.
Yes, although very, very soon afterwards, X-ray astronomy got going and it found tons of them.
I see. You know, but the way you're describing Dr. Burnell, I mean, yours is a response of a typical pure scientist who doesn't exult in the discovery the way perhaps an ordinary person might. You're very matter of fact about it. But this is an enormous thing, even at the cosmic scale, to find something like a neutron star. When did the feeling sink into you about that? Did you reflect later how big it was?
Oh, yes, you do later. But at the time, you have to not get overexcited, shall I say.
Right.
You have to, as we sometimes say in Ireland, keep your head screwed on straight.
Right, right. And at what point did you and your colleagues recognize what you had?
We had a couple of possible pictures of what it might be. And when Tony, my thesis advisor, gave a colloquium for the astronomers in Cambridge and announced this discovery, he was opting for one of the two. But several of the audience reacted very quickly and said, no, I don't think it's white dwarfs. I think it's neutron stars.
I see. It came from the audience.
Yes, particularly from Fred Hoyle.
Oh, Fred Hoyle was in the audience?
Yes, Fred was in the audience, as was every other astronomer in Cambridge.
Oh, that's astonishing. I mean, the great steady stater was in the audience.
Mm-hmm.
Yeah. And then once it was confirmed that this was indeed what you had, what kind of work did you begin as a student?
Well, by this stage, I had 6 months of funding left.
Okay.
And I had to complete the data analysis for my thesis on the thesis topic, write the thesis, submit the thesis, etc. The pulsars went in an appendix because they weren't part of the declared subject for the thesis.
Oh, really? That itself is a great story, that pulsars were in the appendix.
Mm-hmm.
Okay, so and after that, did you elaborate for later purposes of what you had discovered?
We were, as well as writing the thesis, we wrote 2 or 3 papers about these objects. Tony Hewish was the lead author, but I was one of the other authors.
I see. To change tracks a bit, Dr. Burnell, I'm jumping 7 years from 67 to 1974, when something quite extraordinary happened, when the Nobel Prize in Physics was announced. Your supervisor was one of the 2 who won it for the discovery that essentially you made. What was going on in your mind at that point? Because going by your interviews, my sense is you're really playing it down. You're not particularly riled at what happened, unlike your colleagues who were more angry than you were. Tell me what was going through your mind.
Well, by that stage, I was working in X-ray astronomy. And to do X-ray astronomy, you have to get your equipment up above the Earth's atmosphere in a satellite.
Right.
And our satellite launched at 8 o'clock that morning.
Okay.
And at midday, a colleague came rushing into my office. Have you heard the news? Have you heard the news? And I thought, oh, the satellites failed, but it wasn't. It was the announcement of the Nobel Prize on the radio.
And you were not on the names?
No. It's at that stage, it was unusual for a student to be included.
I see. Did gender play any role here at all?
Oh, quite likely, yes. Gender always plays a role.
That's because you made quite striking comments. I was again watching one of your interviews where you're saying that you were pursuing your science at a time when women were not expected to be anything other than sex objects, wives, mothers, and housewives. This is your exact quote.
Yes.
How did you navigate such a rancid male chauvinistic order at that point?
Let me just fill in a little bit more of British background.
Okay.
There's been a world war. The men went off to fight. The women moved out of the home and did a number of the jobs that the men had done before they went off to fight. Then the war ends, and somehow the government has to get the women out of those jobs and back into the home to free up the jobs for the returning soldiers.
Right.
And so through my childhood, there's enormous emphasis on women as homemakers, mothers, wives, etc. And women didn't think of having careers. At least if they got married, they didn't.
Right.
And so that was the kind of ambiance around when I was growing up. So I'm breaking role models by going as far as doing a PhD even.
Right. But did you not feel any kind of slight when the Nobel Prize was announced without any acknowledgement of your work?
I'm quite good at strategy.
Okay.
Until then, there had never been a Nobel Physics Prize awarded to anything astronomical.
Right.
And there's no Nobel Astronomy Prize. The Physics Prize is the only chance astronomers have at a Nobel Prize. And up till then, the Physics Committee had ignored astronomy. So this was a major development that they had recognized something astronomical.
I see.
And I knew that other astronomers would get that prize in due course, which has indeed been the case.
Right.
There's still no astronomy prize. It's still a case that the astronomers are bidding for looking to the physics prize as their only Nobel option.
I see. Did Dr. Hewish at any point after that acknowledge your work in that?
My name would get mentioned, but very much as that of a student under his guidance.
But that's, I mean, I don't want to feel offended on your behalf, but that sounds grossly unjust.
You have to remember that way back in the 1960s, society was different from what it is today.
But I mean, I'm sure after that there have been a lot of years during which if he could have acknowledged much more, right?
Yeah, but I had made the mistake of leaving radio astronomy and getting married.
Oh, okay.
That's two reasons why I can be set aside.
Okay, I see. You know, you made another interesting point in one of your interviews where you said you kept thinking that you were not clever enough to be in Cambridge.
Mm-hmm.
And you developed what came to be known as imposter syndrome. It was not known as that at that point. But what you had was that. Tell me about that. Why did you feel that?
I'd been in the north and west of the British Isles before going to Cambridge. Cambridge was the deep south as far as I was concerned. And southern England, southeastern England, southern England tends to be a bit more effete than the north and west of the country.
I see.
Partly because the weather's nicer.
Yeah.
Right. So Cambridge felt quite an alien place when I first went there. I've now lived and worked in the south of England quite a lot, so I'm used to it now. But first time encountering it, it was quite a different kind of society.
Right. And when finally that particular way of thinking was called imposter syndrome, when it came to recognize as that, did you look back at your life and immediately connected the two?
Yes, I mean, I was aware from quite a long time that it was imposter syndrome I was suffering from. Yeah.
And after these many years, have you discarded it?
Well, I'm in Oxford now, and I'm a Cambridge graduate, and so I think I've probably made the grade.
That's funny. That's funny. You know, I was reading the Nobel citation, 1974 citation for the Physics Prize. And it rankled in my mind. I don't know if it did. It says for his decisive role in the discovery of pulsars, Dr. Hewish's. That has to rankle, doesn't it?
Well, he got the money that allowed us to build the telescope and do the observations.
Right.
And he's supervising the project all the way through.
I see. And what was your relationship in terms of, were you cordial all throughout?
Yes. Yeah.
I see. Now, to change gears a bit, Dr. Burnell, how do you look at the scientific research ecology for women now, after 6 decades?
It's still tougher for women than for men, but there's, at least in Britain, increasing emphasis on questions like what fraction of your faculty are female?
I see.
And if it's a lower number, has that fraction improved in recent years? So questions like that are now regularly asked.
And you see more and more women joining scientific research at pure and applied levels?
Yeah, I can only speak for universities, but yes, undoubtedly in universities. Women are still a minority in physics departments, but it has improved a lot.
And what is your preoccupation these days? Do you continue to teach, or do you continue to do your research?
Most of what I do is what we call outreach. I'm
Okay,
talking to public, to schools, bodies like that.
I see. And do you keep track of, say, something like the James Webb Space Telescope, which is apparently appending a lot of what we believed about the universe, including finding galaxies very close to the Big Bang now, forcing us to think that perhaps galaxies form way more differently than we have believed. They form perhaps way more quickly than what we believe. What is your take on that?
I can't comment on that particular observation because I've never worked in galaxy formation. So I don't know, I'm afraid. But I do watch what's coming from all these new facilities,
I see.
undoubtedly.
And what I mean just last couple of things, if you don't mind, on a slightly loftier question. Having spent these many decades in the field, how do you look at the universe as an entity? Do you continue to find it baffling beyond human comprehension, or you think at some point we would figure it out?
I follow new developments, new discoveries, particularly ones closest to my interest. And I'm aware that there's a lot going on and a great pace of discovery, but I can't really help you with the more existential questions.
You know, it's very interesting. I've interviewed a lot of physicists over the years, and there has not been a single one who hasn't said anything other than what you just said. They do not get into existential questions at all, because I suppose it's the realm of philosophy.
Yeah.
Okay. Do you visit the US at all?
Oh, yes, yes. My next visit is for the Society of Physics students.
I see. And where is that?
That's in Denver in, I think it's November.
Okay.
They meet every 2 years, I think it is. And I've been privileged to visit several of their meetings, which is huge fun.
If you ever happen to be in Chicago area, it would be an absolute pleasure to meet you.
Thank you.
And on that note, I want to really thank you, Dr. Burnell, for your time. I hope it was worth your while finding 30 odd minutes for me. And I will run it over the weekend and send you all the links to your office.
Thank you very much indeed. And I appreciate the time you're giving to this. So thank you very much.